Hello, this is the practice exam for the Unit 1. So something to keep in mind here is that these are a very good indication of what the actual exam questions will be like. So, gauge how well you've done in this practice exam, and based on that, you should pretty well know what to expect when you come in tomorrow. Be very, very diligent about studying for the things that you don't know about, all right? So that's just a point that I want to make. There are lots of materials online for you to access, and so I recommend that you look through those and you prepare as well as possible. This first section here, it is on the lab equipment. There are 23 pieces of lab equipment. There are flashcards that I created for that. I will repost those on the blog so that you have access to those. So make sure that you're following up. Look back through those 23 pieces of lab equipment and make sure you know what each one is called. So that's the first thing there. Okay, so identifying each of these. This first one here is called a test tube holder, which is B. All right. The second one is beaker tongues. That is answer C, D. Oops. All right. And then we've got an evaporating dish. The evaporating dish is answer A, B. All right. So that's that. Lab safety. For this one, they're coming from the two videos that I told you to watch that are in the playlist for lab safety. So make sure that you've watched those things because I could ask you anything from those videos. Even if we haven't talked about it in class, it's fair game. So make sure that you've watched those. When observing the smell of something in a lab, you should know here that wafting is the correct technique. So basically that's taking your hand and trying to move some of the air towards your nose. That way you don't risk getting too much of a chemical in your nose all at once and having some sort of bad chemical reaction where you've got bad chemicals in your nose. If a Bunsen burner is malfunctioning, turn it off by turning off the silver gas valve that's on the lab table. All right, all of those other ways are inappropriate in terms of turning it off. Number 6, Laura's working in a lab and she knows her goggles are starting to fog up. In this case, what she needs to do is she needs to ask to go out to cool off, all right? That's the only way that you can take your goggles off. So don't open the vents. Never open the vents because you don't know when it's safe and when it's not. Don't put them on your forehead because that's not safe. I'll take away all the points for your participation for that lab. And, taking them off even to clean them can be problematic. And then maybe you've got chemicals now on your clothes, which is no good. So be careful about that. Just ask to go out in the hallway, and that's the best way to deal with that. Section C, accuracy and precision. We've got a second grader here, asked how long an Earth year lasts. He says 415 days, 12 hours, 2 minutes, and 15 seconds. Okay, so he's very, very specific here. He goes to the seconds. All right, that means he has high precision. Unfortunately, he's completely wrong. All right, which means he's got poor accuracy. So he is precise, but not accurate in this case. All right, going on to the measurement here. For this, basically the rule is I'm only going to give you things that fall on nice decimal places in terms of the marks. So we've got 1 here for the ruler. We've got 1, and then 1.1, and then 1.2, and then 1.3, and then 1.4, and then 1.5. All right, and you see this falls between 1.4 and 1.5, almost all the way to 1.5. All right, so 1.48 seems like a pretty good estimate. And so what we've done here, if it was marked to the 10th place, every one of these lines represents a 10th. We can estimate to the 100th place. All right, and since it was just before 1.5, we would say 1.48. Because you can see there, it's not all the way to that 1.5 line. It's a little bit there before it. On number 9 here, similar concept. Every one of these marks represents 1. All right, and so we've got 10, 11, 12, 13, 14, 15, 16. All right, because every line represents 1, we can estimate to the 10th place. But what's interesting about this one is it looks like it fell exactly on 16. All right, and because it fell exactly on 16 and we're estimating to the 10th place, we say 16.0 because that has it marked out to the 10th place. So careful about that. Even though it's right on a line, we still need that 10th place in there because that's how accurately, or I'm sorry, how precisely we can estimate there. Alrighty, going on to section E, scientific notation. So here, this is just knowing the basic rules of scientific notation. The number that's provided here is a small number, so we know it's going to have a negative exponent on the 10. We would bump this decimal place over 1, 2, 3, 4, 5 spots to get one non-zero in front of the decimal place. And so what this is 8.96 now, times 10 to that. We moved it over 5 spots, and it's a small number, so negative 5. All right? Now, if you look at the different options there, that option is not actually there. B looks kind of similar, but that's 896 times 10 to the negative 5, so it's incorrect. So since the correct option is not listed, we go for none of these. 411, it says convert 7.2 times 10 to the 6th to standard notation. All right, 7.2 times 10 to the 6th. We know that's going to be a big number, so we're going to bounce the decimal place this way. 1, 2, 3, 4, 5, 6. All right. If we fill in all these empty spots with zeros, all right, you see that there are 5 zeros on that number. It's really, really important that you count the number of zeros because I think a lot of people will just look at the page and they'll see something that's 7, 2, and a bunch of zeros and circle it, and it has to have exactly the right number of zeros. So carefully count zeros in every case. All right, so in this case, 5 zeros is answer A, and that's what we're going to go with. For this next one, this is literally just a calculator problem, so you have to know how to put it in your calculator correctly. Make sure that you show up on test day with a calculator that you're comfortable using. All right, so 2.5 times 10 to the negative third, we write 2.5 E3. And then we're going to then hit the divided by button, and then 5E negative 3. All right. And for that, I get 500,000. All right, remember, count the zeros. Should have 5 zeros. This next one, we're in this section that's dealing with significant figures. So the first thing is just counting significant figures. When we look at this number, there are a couple different kinds of zeros that we have to consider. These two zeros are leading zeros, which means they don't matter. This zero here at the end is a trailing zero. Trailing zeros only matter if there's a decimal point. There is a decimal point in this number, so that trailing zero does matter. All right, so the leading zeros don't matter. The trailing zero does. So that gives us 3 sig figs. The 3 and the 4, of course, any non-zero always matters. So the 3 and the 4 count. That last zero counts. The leading zeros would never count. On this next one, we are doing multiplication division. So we're going to count the number of sig figs in these numbers. That's 3 sig figs. This one is 2 sig figs because that's a trailing zero without a decimal point. So our answer needs to have 2 sig figs. If you multiply these together, you get 800. Okay, that seems all nice, but then you look at all the answers and they're all 800. All right, but remember I said it has to have 2 significant figures. A, if you look at it, those are trailing zeros without decimal points, so that one would only have 1. B is the correct answer because what that overbar means is it means that first zero is significant, the second zero is not. C is incorrect because that would indicate that there were 3 sig figs, and in D there are 4 sig figs, so that's why those ones are wrong. All right, 15, it says perform the following calculation again with sig figs. This time we're using the subtraction rule. All right, the subtraction rule says that we look at the least precise decimal place. This one goes out to the hundredths place, this one goes out to the tenths place, so our answer needs to go out to the tenths place. You put this in your calculator, you get 2.56, but then you need to round that to the nearest tenth. All right, and so we're going to go with C, which is 2.6. On to the last page here, we've got some conversion problems. This first one is metric conversion. All right, you identify that it's metric conversion because it's got these metric prefixes in it, hecto and milli, and then the end, the grams is the same. All right, so we're going from hecto to milli. You have to remember that little mnemonic that I gave you. King Henry died by drinking chocolate milk. All right. Remember that the DA is deca and the D is deci. All right. And we're jumping over from hecto to milli. So that's 1, 2, 3, 4, 5 spots over here. And the decimal point is moving to the right. So we take 7.3. We jump that decimal point over 5 to the right. 1, 2, 3, 4, 5. There are 4 zeros that we've got to fill in here. Okay, it looks like it ends up being 730,000. If you look at the answers there, 730,000 isn't on there, so it's E, none of these. For 17, it says convert 15 miles to meters. All right, so for this one, we start with 15 miles, and then we're going to use the conversion table method here. So starting off with 15 miles, you have to look up on that list and see where we can go from miles. All right. You can see here that miles can be converted to feet, and then feet in turn can be converted to meters. So if we go through that process, we can get from miles to meters. So 15 miles, and then in every 1 mile, we want miles in the bottom so it cancels out. There's 5,280 feet. All right, and then you see in that conversion table up above that for every 3.28 feet, we've got 1 meter. If you go through and calculate that, you should get something like 24,146. In terms of rounding here, if it's going to round to one of the numbers here, it's the same answer. Okay, so if you were going to choose none of these, the thing that you got when you calculated this should have been like wildly, wildly off from any of these answers here. All right, so since you're going to get 24,146 and then some decimals. I just rounded it arbitrarily to the ones place, so be careful about that. And if you're having trouble calculating that, just sort of calculate what the top is, 15 times 5,280, and then write that down and calculate what the bottom is. In this case, it's just 3.28. And then take the top over the bottom, and you should be able to get the correct answer there. If you're having trouble with that, let me know, and I'll show you how to calculate that. Alrighty. Continuing on here, 200 Blix to Wix. So we start off with our 200 Blix. You have to, again, look up at the conversion table up top. You can see that Blix, if we're trying to go to Wix, Blix here can be converted to Glix, and then Glix can be converted to Wix. So we'll go Blix to Glix to Wix. All right. So for the Blix, there are 2 Blix in every 5 Glix. And then there are 10 Glix in every 1 Wick. If you calculate that, on the top we get 1,000. On the bottom you get 20. 1,000 by 20 gives you 50. All right, down here I just ask you a couple of questions from the History of Chemistry lecture that I gave you on paleochemistry. Look over those notes. Most things are fair game. I told you I'm not going to ask you anything about the years, so you don't need to know anything specifically about the years, but especially things where you filled in blanks or big ideas that seem like they're overarching. Those are some things that you should know. So vocabulary as well. If it's a vocabulary word and I had you write it down, make sure that you're familiar with that as well. All right, so Mesolithic chemistry, this is just from the notes. Meso means middle, lithic or lithos means stone. All right, Mesolithic means Middle Stone Age. Bronze is an alloy between what 2 other metals? The 2 metals here are copper and tin. All right, and again, that's just directly from the notes. So make sure you're reading through those, that you're pretty comfortable with a lot of the ideas on there. All right, and that is that. Okay, so this is going to be our first test. It will be a good indication of how well you've been doing in terms of keeping on top of things throughout the entire year. Use this as a diagnostic to see how you're doing in this class. If you don't do well on it, you probably should be changing some things up, all right? And as always, come ask me if you need any help on anything.